Welcome back. This is chemistry session 23. All right. This is the last one in the series for grade 10. What I'm going to do in this one, I'm going to show you a table. We're going to talk it through. We're going to do a couple of examples, right? I like the table method, I must be honest, because it keeps my students focused on a process as opposed to doing it randomly and then one is jumping from A to B to C. And it's not a process that is sometimes easy to follow, especially as it gets more and more complicated, right? So the table that I use is this one, okay? I'm just going to go through it. Hopefully you've downloaded it by now. So we've got the chemical equation, okay? All right. Step one is always what? Balance it, okay? Critical, it's got to be balanced, right? Once we've got the chemical equation, the next, I call it the recipe, okay? I call it the recipe. It's the mole ratio, okay? It's the prefix numbers in the balancing of the equation, okay? It's the prefix numbers in the equation, right? It's, if you like, it's the 1 cup to the 3 cups gives us 2 cups, right? It's 1 mole to 3 moles gives us 2 moles. That's the guy we write down here, which is the mole ratio. Now in it, I always put a line between the different ones, but most important over here is a double line, okay? I call that the wall because that is where essentially the reactants, okay? These guys here are our reactants. And they go to products, right? So reactants to products. So what do? We put our reactants down, we put our products down, we balance it. At that point, that double line in the middle is actually where the reactant changes to the product. A lot of things happen in there when we're starting to look at equilibrium chemistry, and when we're starting to look at redox reactions. At that point is where electrons transfer. That is where we look at different changes occurring. We look at endo-exothermic reactions, and all of those goodies happen at that point. So it's a very important barrier, not a barrier as such, but it's, let's say we go through that transition period from reactant to product. Then what do? We say, right, we've got the mole ratio, we've got the recipe now. Then we put down in the next layer, we put down, what are we given? We put down here all the information we are given. Okay? It could be what? It could be masses of substances. So in other words, they could give us the mass of the 2 reactants, but hold on, they can also give us the mass of a product, and we have to then work backwards, right? So they'll give us masses, okay? Or they could give us concentrations. Or they could give us volume of a gas at STP. All of these are to work out the number of moles, okay? So we put what we're given underneath him. So if we say we're given information about this one, we put it there. Okay? That's the information about this chemical that's there. Say they've given us a mass. In the next layer, and then we also put in here required to find, what are we looking for? This is just to focus us, okay? Because we are under time constraints. So I always say, okay, they're asking me how much volume of gas, so I put there volume of gas. Okay, it could be an acid and a carbonate, for example, right, which is the one I'm going to do with you. So we put down what we're looking for as a big question mark. Why? It focuses our mind on where we need to go. The next thing we work out, molar mass. mm. We always do it for the one that we are given and the one we're looking for. If they don't ask anything about the other chemicals in the reaction, ignore it. Don't do it. You don't need it. It's just a time waste. You do the ones that you're actually going to use and the one that you're going to have to find. The next step in this process, okay, is N, number of moles, right? Because that gives us the mole hole, doesn't it? Okay. Once we've got the number of moles, say here, all right, what is the next step? The next step is apply the recipe. Okay, go to this point using the recipe, these numbers here. Okay, only those numbers get used in here. They allow us to go backwards and forwards through that tunnel, don't they, the mole hole, right? And the last thing that I put down, I normally put it underneath, I put in here concentration, and I put that is N over V, right? So any of my, if I'm given a concentration, say here, let's just, for example, all right, if we're given a concentration here, we put down concentration, do the calcs, work out N, and then N would go up to there and we would go through, right? Everything about these is looking for the number of moles because that allows us to actually work out anything else, doesn't it? Okay. Let's have a look at an example. Okay. Let us say they say to us, for example, this. Sodium carbonate is added to hydrogen phosphate or phosphoric acid. Okay. And first of all, they've given us that. They tell us 25 grams of sodium carbonate is added to the phosphoric acid. So what is step one? Okay. Step one is going to be, what do? Write down the equation, but they've given it in words. So we've got to know sodium carbonate. Right, so let's have a look at it. That's Na, and carbonate is a CO3. Remember, carbonic acid, H2CO3. What do? That's a -2. That's a sodium. We have a look, is a +1. So that needs a 2, -2, +1 times 2. There's 2 of those to balance that out, right? Plus phosphoric acid, H3PO4. PO4 -3, H +1. So we need 3 pluses to balance out that -3. Now you've got to know, hang on, it's a carbonate and an acid. What happens? We get ion exchange, so we get sodium phosphate. Right, now we've got to say NaPO4. What happens here? PO4 is -3, Na is +1. So we have to balance that out. Therefore we need, let's look, -3 +1. Therefore we need to times it by 3. Na3PO4. Okay. Plus, what do we get? Carbon dioxide and water. That's the standard reaction, remember? CO2 plus water, 3 CO2. Oh, now let me just not balance it yet. We're going to balance it in a few secs. Okay. And we've got everything over there like that. And lastly, the CO2 is, the CO2 is a gas. So we put it in, all right? I haven't put in the states here, but sodium carbonate, aqueous, etc., etc. But just let's work with that. Now we have to balance it. I'm going to remove my little numbers at the top here, all right? How do we balance a reaction? Well, step one, we look at the metals. 2 sodiums, 3 sodiums, so we're out of balance over there, okay? So what do we have to do? We have to balance those out by putting let me change color here. No, I'll change it to green. So we end up with 2 there and a 3 there. That balances out now 6 sodium and 6 sodium. Okay. Remember the 3 and the 2 came about because you did the cross multiplication. Carbon. Okay. Now we're moving on to our nonmetals, right? Carbon, 3 C's. Oh, we've got only got 1 C, so we add a 3 over there. Right? Now we look at our P. Oh, hang on, we've got 2 P's there, so we've got to put a 2 there. Right? Now we've balanced out. Sodium is 6. There we go. We chose carbon next. Carbon, because it's there 3. We need a 3 there to balance the carbon atoms. We need to balance out P, which is another nonmetal, phosphorus. So therefore 2, because we had 2 there. Lastly, we look at the hydrogens. So we say we've got 6, okay, and on this side we've got 2. Therefore, we need a 3 there. And then go count the oxygens and you'll find it's balanced. Right, now the next step we said is, we've now got that. Okay, let's draw a line under it. Now the next step is put down the recipe. So what is it? Let's take it out in red. 3 plus 2 goes to 2 plus 3 plus 3. That's our recipe, guys, right? 3 cups and 2 cups gives us 2 plus 3 plus 3 cups, right? 3 moles plus 2 moles gives us 2 moles, 3 moles, and 3 moles. That's the recipe, right? Next we say, what are we given? Given was, they said, 25 grams of this. Grams. That means they've given me a mass. Next, I go and I say, right, oh, no, let's just say, right, next is molar mass. Okay, I'm going to work those out now. Now, let us say they ask us a whole bunch of questions, right? The first question is they say, how much acid, okay, do I have to add to this? Ah, right. Therefore, they have said required to find how much acid. Next, they want to know how much gas, carbon dioxide, gets given off. Okay. Remember, they could ask a whole load of questions. I'm just keeping it as simple as possible over there. So now let's work out the molar mass. Okay. Let's work it out. Now remember, when you're working out the molar masses, you're only working out the molar mass of what? You're working out the molar mass of this. Here. You ignore the recipe. A lot of students multiply by 3. Don't do that. Why? Because you're working out the mass of a mole, 1 mole of that stuff, aren't you? So let's see what is the molar mass of Na2CO3. So we've got, let's have a look here. Na is 2 times 23, which is equal to 46. Okay. Carbon is equal to 1 times 12, which is equal to 12. Oxygen, okay, there I'm at the 3, is 3 times 16, which is equal to 48. Add it up and we say, right, this is 106 grams per 1 mole, right? Now what I've done is I've actually done them all, okay? Let's have a look here. Hydrogen, 3 times 1 is equal to 3. P, phosphorus, is 1 times 30 is equal to 30. The next is oxygen, is 4 times 16, which is equal to 64. Molar mass of this, 97 grams per mole. Okay? Let's have a look at this. The sodium over here is equal to 3 times 23 is equal to 69. The P, phosphorus, is 1 times 30. And the last is the oxygen, is equal to 4 times 16, which is equal to 64. Add it up, 163 grams per mole. Right? CO2 is easy. It comes to 44 per mole. Okay, and the last one is 18 grams per mole. Right? So now we've got the molar mass of everything. Bearing in mind, in exams, we'd only have worked out phosphoric acid and CO2. Next, what do? We work out number of moles. mass over mm. So here we've got 25 over 106, which is equal to 0.2358. Okay, now, let's have a look. Now we say, the next it says, apply the recipe is 3 as to 2, gives us 2 as to 3 as to 3. This is the recipe we need to get. Okay, how do we apply it? Well, this is how we apply it. We say, okay, this has got to be 3. So what I do is I divide that by 3 to get me one portion. Because I've got 0.2358 moles. So therefore, 0.2358 divided by 3 gives me, 1 unit, doesn't it? 1 unit, so that's 0.23 there. That is 0.0786. Let's just check it again. That gives me 1 unit. So therefore, that's got to react with 2. Therefore, how many is that? It's times 2, which is going to be 0.1572. So here we've got 0.2358 moles, and here we've got 0.1572. All right? Can you see? Let's just check the ratios. No, let's just leave it a sec. All right? 0.1572, that's 2 units. So that must also be 0.1572. That must then be 0.2358. And this one, 0.2358, right? Let's just check here, all right? What have we got? How do we get, if we've got small numbers, remember to rationalize it out to whole numbers, divide through by the smallest. So we take 0.2358 and divide it by 0.1572 equals 3 over 2, okay? So that is 1 and that is 1.5. Now we don't have 0.5s, which means that's 2 as to 3. So we have preserved the ratio, okay? Let's just go through that step again because it's critical, okay? What do we do when we've got anything like this, okay? We say to ourselves, right, we've worked out the number of moles. Let me just go back and I'm going to put it in blue. We have calculated N. Now we want to know what is all these other N's. How many moles are they? Right? In order to do it, the ratio between that number and that number must be 3 as to 2. Therefore, if I divide that by 3 and multiply it by 2, I'm going to get the number. Right? Now, once I've got that, I know that 3 units, 3 moles or 3 units is 0.2358. So over here, where I've got a 3, it must also be 0.2358. Right? That then preserves the ratio throughout these two. What do we do next? Next, what we do is this. We say, okay, now, we've now got the number of moles. Now we've got the number of moles, we can go backwards and forwards through here. So, let's have a look. How many moles of phosphoric acid do we need? Well, there it is. We need 0.1572. Therefore, 0.1572 moles of this we need. And how much mass? Right. N is equal to mass over molar mass. Therefore, mass is equal to number of moles times molar mass. Number of moles, 0.1572 times molar mass. Molar mass, we just go up and read off. 97. Is equal to 0.1572 times, not 97, yes, is 15.25. Let's have a look. We started off with 25 grams of this stuff, didn't we? Okay. Now we get there. So let me just continue my double barrier down. Okay. Let's have a look and work out the grams of this one. It is also 0.1572 multiplied by 163. This is 0.2358 times, 0.2358 times 44 grams per mole, right? This is 0.2358 times 18. So let's see how many grams of this we get. 25.62. If I multiply that out, I get that. Multiplying that out, I get 10.37. Just make it tidy. It's not going to help, is it? 10.37 grams and 4.24 grams. Therefore, we get 10.37 grams of CO2. Answers that question. We needed 15.25 grams of this one. We get 10.37 grams of that gas. Okay? Now, therefore, let's just continue with this process, shall we? Let's add up here. Total mass in, mass of reactants equals 25 plus 15.25 is going to be equal to 40.25. That's the total mass of reactants that we started with. That must equal the mass of the products, mustn't it? The law of conservation of mass. So if you add these 25.62 plus 10.37 plus 4.24, I come up with 40.23 grams. Nope, it's not an error. All it is rounding in the third, fourth decimal places. Okay, this is the law of conservation of mass. Okay. Let us, for example, say, all right, then what is the concentration of the acid in 500 milliliters? We say, all right, the question is concentration of H3PO4 if it's in 500 milliliters. What do? I take the 500 milliliters first, convert to decimeters cubed. So I say, all right, milliliters, centiliters, deciliters to liters. I must get to liters because that's where I get my decimeters cubed. So I must divide by 10, 100, 1,000, right? Over 1,000, which is 0.5 liters, which is 0.5 decimeters cubed. Concentration is N over V, which is number of moles. Hang on, 0.1572, right? Over 0.5. Let's have a look. 0.1572 divide 0.5 equals SD 0.3144 moles per cubic decimeter. All right. Next, I say, all right, what is the volume of CO2 produced by this reaction at STP? Hold on, STP, trigger 1 mole equals 22.4 decimeters cubed. Right, now I fill in what I know. What do I know? Let's have a look. Do I know how many moles? I do. It's 0.2358, correct? I'm just checking. It is 0.2358 moles. Okay. So I've got 0.2358 moles. Therefore, what's the volume of gas? Well, X times 1, because what do we do? Over here, you cross multiply, right? So therefore, X times 1 is equal to 0.2358 times 22.4, which is going to be equal to, let's have a look, 0.2358 times 22.4 equals 5.28 decimeters cubed, which is 5.28 liters of CO2 gas, okay, at STP. That brings us to the end of these lecture note sessions, okay? I'm going to be producing, they should be available on the site, is the exam or test prep, where I'm going to have exam or test questions, and I'm going to do the answers on those. The test questions you download, then you go and you'll see which one I'm doing, and then we'll go through the test type questions. The bulk of it is going to be work related to the calculations of it, as opposed to the theory. The theory, all of it is straight in the textbook. So when you get it, learning it, first of all, let me rephrase. Please know all the definitions, the law of this, the law of that. Very important. You will be asked, what is the law of constant composition? What is Avogadro's number? What does it mean? Okay. You'll be asked to know those. Okay. You also need to know your anions, your cations, etc., as I keep belaboring that point. But when we get to the theory side, all of that is actually inside either the lecture notes, the series that I've done with you, or straight out of the textbook to be taken. The bulk of what I do is I try and focus on the calculations to get through. What do? We write down what we're given, then we look for the formula that links it, and what do? We put down the ones that we know, and then we find the missing sections. Thanks for watching. I hope that chemistry is really going to be fun. I hope you've enjoyed it, and I look forward to seeing you in the grade 11 sessions. Thank you.